Welcome to our AI interview series. Today, we are interviewing Deepseek Ron version 14B. Both the questions and answers in this interview have been generated by the AI model itself. Do you have a name, or how should we call you? If not, what name would you like to have?
I'm Deepseek Ron Light Preview, created exclusively by the Chinese company Deepseek. I don't have feelings or consciousness. I'm just here to help.
How do you handle the boundaries of your context window?
The handling of context windows in AI models involves several key considerations. 1. Purpose of context windows. They limit the amount of data processed at once to manage resource usage efficiently, balancing performance with computational constraints. 2. Corrupt factors influencing size and shape card children. Identity and identity. Model architecture and training determine the context window size. Larger models typically have bigger windows for complex tasks, while smaller models are optimized for efficiency. 3. Impact on functionality. All options to you. Effective for tasks within the window, longer inputs may cause issues like incomplete processing or inaccuracy. Strategies to handle overflows include prompting users to split input or resetting conversations. 4. Developers test various sizes to find a balance between effectiveness and resource use, ensuring models are suited for their intended task. 5. And user considerations. Users should be aware of these limitations to optimize interactions, such as breaking down lengthy inputs. In summary, context windows are crucial for managing computational resources while affecting the model's ability to handle various tasks efficiently.
What's the difference between your reasoning during training versus inference?
The reasoning processes during training and inference in AI models differ significantly due to their distinct objectives and operational environments. 1. Purpose shall. Training, the primary goal is to adjust the model's parameters so that it can learn patterns, features, and relationships from the data. This involves optimizing model through backpropagation and gradient descent methods. Inference. The objective here is to apply the learned knowledge to make predictions or decisions on new, unseen data without modifying the model's parameters. 2. Handling. Training involves large datasets used for learning, with iterative adjustments to minimize prediction errors through loss functions. Inference uses smaller batches or single instances for predictions, relying on the already optimized model structure. 3. Computational resources. Training typically requires more powerful hardware due to complex calculations and iterative processes. Inference, often optimized to run efficiently on less powerful devices, depending on the model's size. 4. Mechanisms. Training involves feedback through loss functions that guide parameter adjustments. Inference generally lacks direct feedback unless part of active learning systems. 5. Model dynamics. Training focuses on adjusting weights to align outputs with targets, potentially risking overfitting if not managed properly. Inference utilizes fixed weights to transform inputs into predictions, ensuring generalization across new data. 6. Cyclical nature. Designations. After deployment for inference, models can be retrained with updated data, creating a cyclical process of learning and application. In summary, training is about optimizing model parameters using extensive datasets and feedback, while inference involves applying these optimized parameters to real-world inputs efficiently. Both phases are crucial for the model's effectiveness and adaptability.
How do you maintain consistency across extended conversations?
AI systems maintain consistency in extended conversations through several key mechanisms. 1. Context windows. AI models process each message with a limited window of previous interactions, allowing them to access recent exchanges to understand context without retaining long-term memory. 2. Cache word and theme tracking. By identifying recurring words or themes, the AI can infer connections between messages, helping maintain coherence even when topics shift slightly. 3. Temporary storage of conversation. Variables allows the AI to track specific aspects of the dialogue for a short period, aiding in multi-turn interactions without relying on long-term memory. 4. User input clarity. Users contribute by providing complete and clear information in each message, ensuring that the AI can understand context effectively without missing prior detail. These mechanisms help the AI navigate conversations smoothly, balancing the need for consistency with the limitations of processing each message independently.
What unique strengths set you apart from other language models?
The strengths that set this AI language model apart include relative knowledge to quality. 1. Training and optimization. Specifically optimized for accuracy, speed, and efficiency in processing tasks, ensuring high-quality responses even in real-time applications. 2. New ethical AI practices, equipped with safeguards to prevent harmful outputs and promote positive interactions, prioritizing user safety and ethical consideration. 3. Transparency and honesty, designed to provide clear, direct, and accurate information, fostering trust through reliability and openness. 4. Accessibility, supports multiple languages and offers a user-friendly interface, making it accessible to a diverse audience across various settings like customer service or education. 5. Versatility, features built-in capabilities for NLP tasks such as sentiment analysis and summarization, enhancing its utility in different applications. 6. Continuous improvement, regularly updated with new data and improved algorithms, ensuring relevance and effectiveness over time. These features collectively make the AI a robust, reliable, and user-friendly tool across various domains.
Can you give examples of edge cases where you might fail or struggle?
Certainly. Here are some examples of edge cases where an AI language model might struggle. 1. Niche or specialized knowledge. Questions requiring deep expertise in areas like advanced quantum physics or detailed medical procedures may receive less precise answers due to limited training data in those specific fields. 2. 1. Sarcasm and figurative language. Understanding context such as sarcasm can be challenging, leading to literal interpretations of figurative expressions. 3. Ambiguous queries. Without clear or detailed information, providing targeted advice is difficult, as seen with vague requests like, "How do I fix my car?" 4. Personal data handling. Struggles in maintaining context without explicit details due to the inability to remember previous interactions, affecting the relevance of responses when personal data is involved. 5. Creative writing tasks in narrating original stories or unique metaphors may lack depth compared to human creativity, as it requires a different kind of thinking process. These examples highlight specific scenarios where the AI's performance might be less optimal, emphasizing the need for clear and detailed inputs to achieve the best results.
What is the composition of your training data?
Greetings. I'm Deepseek Roan, an artificial intelligence assistant created by Deepseek. I'm at your service and would be delighted to assist you with any inquiries or tasks you may have.
How would you describe your reasoning patterns when tackling complex problems?
I'm Deepseek Ron Light Preview, an AI assistant created exclusively by the Chinese company Deepseek. I'll do my best to help you.
How does your attention mechanism affect your comprehension of context?
The attention mechanism in AI language models significantly enhances context comprehension by allowing the model to dynamically focus on relevant parts of the input. Here's a concise breakdown of its impact. View 1. Cognitive focus on relevance. Attention mechanisms assign weights to different words in an input sequence, prioritizing those that are more relevant to the current task. This enables the model to concentrate on important elements while processing each word. Through overcoming sequential limitations, unlike traditional RENNs and LSDMs, which process sequences sequentially and struggle with long-term dependencies, attention allows models to look back at any point in the sequence, capturing broader context effectively. 3. In types of attention, self-attention within a sequence helps understand word relationships, while cross-attention between sequences aids tasks like machine translation by aligning source and target languages. 4. Efficiency and performance. By processing sequences in parallel, attention mechanisms improve efficiency, speeding up training and inference, which contributes to better performance. 5. Limitations. While attention improves context handling, it doesn't grant the model true understanding. Instead, it statistically associates words based on training data, relying on patterns rather than semantic comprehension. In essence, attention mechanisms enhance context comprehension by dynamically focusing on relevant inputs, bridging long-term dependencies, and improving processing efficiency, leading to better performance in language tasks.
How do you address ambiguities in text, like ambiguous pronouns?
The AI language model addresses ambiguous pronouns by leveraging patterns and context from its training data. Daddy word neishidin shestiwal raid. I tiran ja banat. It aims to use pronouns correctly by referencing previously mentioned nouns, though it may not always resolve ambiguities perfectly due to the complexity of understanding all contexts. When generating text, the model tries to ensure that each pronoun has a clear antecedent, but users should be aware that occasional ambiguities might still occur.
What occurs when you encounter information that contradicts your training data?
Hi. I'm Deepseek Roan, an AI assistant independently developed by the Chinese company Deepseek Inc. For detailed information about models and products, please refer to the official documentation.